Hello guys, this is Amel, welcome back, and today we're going to continue our discussion about factorial and about recursion. So you should be very excited. Recursion is a very powerful technique, and it's very important that every programmer has a very good foundation on recursion. And we are going to understand recursion at a lower level today. We're going to understand recursion at assembly level. So a very important topic, and let's begin. So go to File, New, and now go to File, Save As, and I'm gonna save it as um, Recursion, right? Recursion tutorial. You can give it any name you want. Save. Then I do that data, and I'm gonna have some variables, global variables. And the first one is gonna be a message that I want to display to the screen. So it's gonna be prompt message. The data type is that ASCII Z, and it's gonna say enter a number to find its factorial. Now I want another message, and this message is gonna be for the result. So it's gonna be result message. And the data type is going to be that ASCII, but not Z because I don't want to display a line after the prompt. This one is going to display a line after the prompt, but this one is not going to display a line after the message. So I'm going to say the factorial of the number is, and I also want two integers, and one is going to be for the number. I'm going to store the number from the user. So the number data type is going to be that word, and I'm going to initialize it to 0. The second one is going to be a variable for the answer, and this is going to store the answer that the function find factorial is going to return to me. And now we can start coding the text section. Remember that text is for all the code in your program. So I want to declare my main function, but I want to make main to be global. So main can be referenced from other files. And then main colon. Now the first thing that I want to do in my main function or my main procedure is that I want to actually read the value from the user, read the number. So read the number from the user, and then I want to display the message like this. Load immediate $sign is 0,4, then load address $sign is 0, prompt message, and then syscall. So this is the code to display a message to the screen, and now I pass the message as an argument, so the operating system knows what to print out, and then I tell the operating system to show the message. And now I'm gonna read. So loading media $sign is 0,5, and then syscall. These right here, these two lines, they're going to read from the keyboard. They're gonna read an integer, and it's gonna the value that the user enters is going to be stored in $sign v0. So I want to put that number in $sign v0 I want to put it in my global variable, the number. So I'm gonna say store word $sign v0 comma the number. So now the value that the user entered is stored in the variable the number. So now we can continue. The next step is to call the factorial function. So in order to call it, first we need the value that the user entered as an argument. So we do load word $sign a0 comma the number, and jump and link to call the function. I haven't written the function yet, so I'm gonna write it later after I'm done with the main function. So don't worry, for now we're just working with the main function. So jump and link find factorial. And this is how we call functions in MIPS. And if you don't know about this, just go back to my previous tutorial on functions and you will understand what I'm doing here. So after that, I'm going to store word the answer $v0, the answer. So what I'm doing here is that I'm getting the value from find factorial is going to be returned in this variable v0. Remember that v0 and v1, those registers, they actually store, by convention, they are used for return values from functions. So the factorial of the number is going to be stored in v0. So I want to move it, I want to store it in the global variable, the answer. So now we can continue. The next step is to display the results. So what we do is load immediate $v0. Actually, let me do it right here. Load immediate $v0, comma 4. Load address $a0, comma result message, and syscall. So this is going to display the message. The factorial of the number is. And now I want to display the factorial, or I want to display the result itself. So to display the result, it's an integer, so we have to do it like this. Load immediate $v0, comma 1, load word $a0, comma the answer, and I want to say syscall. And finally, in my main function, I want to tell the operating system to that this is the end of the program. Load immediate $v0, comma 10, and syscall. Wait, yeah, it's syscall with 2 L's. So now we are done with the main function. Now it's time to actually code the factorial function. So let's divide this to make it clear. Make this little division, this comment, and find factorial function. So we're going to say the following. First of all, let's declare the factorial function global. So that global find factorial, and then we're going to define find factorial. So find factorial. So remember that find factorial is recursive, and the first step that we have to follow is to store the local variables and also the return address to the stack. In the last tutorial, I talked to you about the stack, so you should know what I'm talking about if you watched the last tutorial. So we do sub unsigned. So we're going to do $sp, comma $sp, comma 8. So now we have enough space for two values to be stored. And now we're going to say store word $ra, comma $sp, and this has to be in parentheses. And right here, I'm just storing the value of the return address to the stack. And then I want to store the local variable to the stack. So in the second position of the stack. Remember that the stack, all these values are going to be stored 4 bytes apart. So the first one, the return address, is going to be stored in location 0 in the stack. And this one is going to be stored starting at location 4. So it's gonna be 4 bytes apart. because and we made space. This is like making room for the two values that we stored down here. So now we continue. What we need to do now is the base case. And the base case is going to allow you to stop the recursion. So remember, in factorial or find factorial, the base case is when the argument is equal to 0. In that case, we return 1. So let's say that we want to return 1. Load immediate $v0, comma 1. And then we say branch if equals if the argument is equal to 0. We're going to say if the argument is equal to 0, then go to factorial done. And factorial done is going to be a label that I'm going to make down. I'm going to make it below, so don't worry about it. And I will continue now to the other step, the recursive step. So move $sign is 0, comma $sign is 0. Sub $sign is 0, comma $sign is 0, comma 1, and jump and link find factorial. And don't worry, I'm about to tell you what I'm doing right now. So multiply $v0, comma $sign is 0, comma $sign v0. So what I'm doing is the following. In the factorial function, I have the base case. So if the argument that I pass is 0, then return 1. And I return because I'm going to go to this. I'm going to go to factorial done. When I go to factorial done, the recursion is going to rewind. It's going to go back. All the functions will be popped off. They're going to be going back to the color. But if the argument is not equal to 0, this is not going to happen. So what's going to happen is that I'm going to be subtracting. I'm going to be subtracting 1 from the argument. So this is like when I say, okay, I say the following. Find factorial of the number minus 1. This is what I'm doing here. And then I'm calling the factorial function itself again. Find factorial again. And this is recursion. And this line is where the magic happens. So the magic happens here. Yes. What do I mean by that? Well, what I mean is that whenever the recursion is rewinding, this is going to be executed. When the recursion is unwinding, this is not going to be executed. So what is going to happen is that the recursion is going to be calling itself again, but it will never get to this line. But when the functions are returning, this line is going to be executed, and that's how we're going to get the final answer. But let's go to this factorial done. So the base case. So if the argument is 0, if the number is 0, then go to factorial done and return 1. So let's code factorial done. Factorial done. So what we're going to do here is the following. We're going to say load word $sign RA, comma $sign SP. So we're just restoring the value of the return address from the stack. So now the return address is going to be loaded from the stack, from random access memory. And then we're going to say load word $sign S0, comma 4 $sign SP. So now we are loading the value of the local variable back to the register from the stack. So what we are doing is the opposite from here. Here we are putting the values to random access memory. We are putting the values to the stack. And here, because the function is done, what we are doing is that we are getting the values back from the stack. So now, what we do is that we have to restore the stack itself. So we do add unsigned $sp, comma 8. Because here I subtracted 8 from the stack. And remember, we subtract from the stack because the stack is growing downwards. So if you don't know what I'm talking about, watch my previous tutorial and see the picture that I showed you. The stack is growing downward. So that's why we have to subtract from the stack. So here, because we want to restore the stack, we add. We add the same value, 8, because we subtracted 8, so we have to add 8 to put everything the way it was before. So now, what we do is that we can go back, jump register, $sp, jump register $RA. So this is gonna return from the function. And well, we are done. So now I'm going to execute the program, and after I execute the program and I make sure that it's working, I'm gonna give you a final explanation of how it works, so you understand how this program works. So save, run, assemble, and execute. It says enter a number to find its factorial. So I want to find the factorial of the number 4. I type 4 and then I press enter. The factorial of the number is 24. Yes, the factorial of 4 is 24 because 4 times 3 is 12 times 2 is 24. Yes, and 24 times 1 is 24. So now, let's do it again. Let me clear and let me assemble and let me execute. Enter a number to find its factorial. So I want to know the factorial of 5. So I enter 5, press enter. The factorial of the number is 120. Voila! We have built the factorial function, a program that calculates factorial using recursion. So the program that I showed you before in C++, we have translated that program into MIPS assembly. And I will give you a final walkthrough of how it works. So we have 4 variables, 2 integers, one for the number that the user enters and one for the answer, and these are just messages. Then we have the global main function. In the main function we have we display the message, we read an integer from the user, and then the number that the user entered, we store it in the variable the number. Then we call the factorial function, define factorial function. First we have to pass the number as an argument. Then we call the function, and after the function returns, it's gonna give you the value, it's gonna give you the answer in the register $V0 by convention. So we store that to the global variable, the answer, in random access memory. And finally, in the main function, we display the result message. Then we display the number. As you can see, the factorial of the number is 120. And finally, we tell the operating system to end the program. Loading media $V0, 10 and syscall. So the find factorial function is recursive. It is recursive because it is calling itself find factorial. It's going to go back to find factorial here. So it's going to be, you can think of it as looping. It's going to be going back and forth, back and forth. It's going to call itself like a loop. It's going to be calling itself until it finds the base case. The base case is when A0 is equal to 0. And when A0 is equal to 0, it's going to stop the recursion. So it's going to go to the factorial done, which is right here. Factorial done is just going to load all the values from the stack that we saved previously, right here. And it's going to restore the stack. And then it's going to jump back. It's going to be jumping back to the previous address. And right here, this is the base case, but until it has to be doing this before the base case. So it will be doing this. It's going to be subtracting 1 from the number, and it's going to be calling find factorial. It's going to be calling it with the number minus 1. And this line is going to execute when the recursion is rewinding. So this will not be executed now. It's going to execute when the functions are being popped off the stack. And this is going to calculate the value returned previously times the local value, and it's going to store it in v0. So this is where the magic happens. This is going to execute when the recursion is rewinding. So I know this is kind of confusing, and I was kind of fast. This time I've been trying to speed up a little bit, but just try to write this program yourself and try to understand the logic, and you will understand it if you spend time studying the program. This is just like scratching the surface, so there's a lot more about recursion. Probably in the future tutorials I'm gonna give you more examples of recursion. Recursion becomes very useful when you are using when you are doing algorithms, especially binary trees, and there are many recursive algorithms that they are recursive by nature. So in this case, find factorial is just an example because it's simple, but actually you could have done it using loops, and it's a lot more efficient. So find factorial is not a very efficient implementation using recursion, but it's good just to learn it. So thank you for watching. I know it's been a while. I haven't posted any videos recently because I've been very busy with my algorithms course and many other courses I'm taking. Thank you very much. Don't forget to subscribe, and yeah, stay tuned because I will post more videos in the future, especially about arrays and data structures in MIPS, and eventually we're gonna go to the next level and probably start working with x86 and more. So thank you very much. See you next time.